In this video, we're going to look at some examples of calculations involving strong acids. Strong acids are generally easier to work with than weak acids because we know that they completely dissociate. So in this problem involving nitric acid, I know that all of my nitric acid is going to be converted into hydronium ions. So I'm going to use a one-sided arrow, not an equilibrium arrow, because I know this reaction is going to go to completion. So whatever my concentration of HNO3 was when I made this solution is going to be equal to the H3O plus concentration. So all I need to do is use the pH to find the H3O plus concentration, and that was, or is going to be, the concentration of the nitric acid. So we know that to get the H3O plus from the pH, we're going to do 10 to the minus pH. So 10 to the minus 0.70 is going to give us 0.200 molar nitric acid. And that is our final result, because we know that the dissociation is complete. So whatever the hydronium ion concentration is, that's essentially what the nitric acid concentration was when I made the solution. Okay, in this example, we want to know what is the pH if I take 5 grams of sulfuric acid and dissolve it in enough water to make 250 milliliters of the solution. So all I really need to do is to determine the concentration of sulfuric acid. That will tell me the concentration of hydronium ions, because sulfuric acid is a strong acid. And once I have the H3O plus concentration, I know how to get the pH. So I picked this example specifically with sulfuric acid to highlight polyprotic acids. So in polyprotic acids, we generally only worry about the first hydrogen coming off. So in sulfuric acid, even though it's H2SO4, it's really only the first hydrogen coming off that we're worried about. So H2SO4 is a strong acid. Its conjugate base, HSO4 minus, is in fact a weak acid. And so this might dissociate a little bit, but due to the fact that we're producing a ton of H3O plus in this first reaction, that second hydrogen is going to hardly come off at all. And so all I really need to do is worry about the first proton coming off. And so all I need to do is calculate the molarity of sulfuric acid. That will be the molarity of H3O plus. And once I have the molarity of H3O plus, I can find the pH. So in order to determine the molarity, we know that the molarity is equal to the moles over the volume. So I know the volume. I just need to get the moles. So I'm going to take my 5 grams of H2SO4 and convert that into moles. Now I'm going to assume you know how to calculate molar masses, and so I'll just tell you that the molar mass of sulfuric acid is 98.09 grams per mole. So I take my 5 grams, that's going to give me that many moles. So then I'll take molarity is moles over volume. And remember, I need to convert this from milliliters into liters. So there are 1,000 milliliters in a liter. So we can go 1, 2, 3. So 250 milliliters is 0.250 liters. And so my concentration comes out to be 0.204 molar. And so this is the concentration of sulfuric acid, because it's going to completely dissociate. This is also my concentration of hydronium ions. Okay, so once I have the concentration of hydronium ions, I can use the pH is the negative log of the H3O plus concentration and so I get a pH of 0.69. Okay, so one more example. I want to know what mass of HBr needs to be used to make 500 milliliters of a solution with a pH of 2.5. But again, because this is a strong acid, all of my HBr is going to dissociate to make H3O+. So the fact that they gave me the pH means I can calculate the H3O+ concentration. So that's going to be equal to the HBr concentration. Once I know the concentration, so I'll find the concentration from the pH. They gave me the volume, so I know that. And so all I need to do is calculate the moles. And once I know the moles, I can calculate the mass, and I'll be able to solve the problem. So to get the H3O plus concentration from the pH, I'm going to use the H3O plus is 10 to the minus pH. So I'm going to do 10 to the minus 2.5. And so the concentration of H3O plus is 0.00316 molar. That's going to be equal to the concentration of HBr. So now I'm going to use that M is equal to N over V. Or what I'm really interested in is the moles. So the moles is equal to the concentration times the volume. And of course, molarity is moles per liter. I need to convert this into liters. So 500 milliliters, I'm going to go 1, 2, 3. So that's going to be times 0.5 liters. And my moles of HBr is going to be 0.00158. All right, so I know how many moles of HBr I have. To convert from moles to mass, I need the molar mass. I'm going to assume you know how to calculate that, so I'll just give you that the molar mass of HBr is 80.91 grams per mole. So we're going to need 0.128 grams of HBr.